Hi, everyone. Yeah, as Derek mentioned, I'm Dan Williams, CEO of Measurable, and I'm really excited to tell you all about measurable energy and where we've got to over the past few years. So 2 years ago, Josh Eady, my co-founder, and I founded Measurable Energy. And basically our aim for founding the company was to find a real and effective way of identifying and then eliminating wasted energy and the associated greenhouse gas emissions from commercial buildings. It's always been a very obvious thing that when you walk around buildings that there is quite a lot of wasted energy, and there's not really any way to either monitor that or control it. So we've spent a couple of years coming up with the measurable energy platform, and really happy to take you through where we've got to during that 2-year period today, and also kind of finish with a few ways that perhaps you could help us and join in and potentially save energy in your own commercial building as we go forward. So to start with, I want to really just make it really simple and clear as to what the measurable energy platform can do for building occupants, for building managers, for facilities managers, people that spend time managing buildings. Essentially, all you have to do is take our measurable energy power socket, and that's the power socket you can see on the screen there. Forgive me, that's a UK power socket, but of course, power sockets across the globe are, they do the same function, just in a different form factor. But essentially, we swap out the old power socket, or you install it if it's a new building, and kind of just sit back. It's designed for you to sit back and let our machine learning software save at least 20% of your building's energy consumption. And of course, energy consumption leads to reductions in greenhouse gas emissions and also energy costs as well. So it's a pretty big claim, and I want to take you through the steps that we got to this system and why it's important. So let's go to the beginning, all about something called small power, and sometimes small power is known as plug load power. Essentially, it's that energy load of a commercial building that isn't lighting or heating and ventilation and air conditioning. The pie chart you can see on the screen is very roughly an energy profile of an average office building in the UK, and probably the same in the EU and the US and any other commercial building in the world. Roughly less than a third these days is attributed to lighting. Roughly over a third is heating and ventilation and air conditioning systems. And then there's this other unregulated load, which is known as small power. And that can be from anything from sort of 20% all the way up to 50% of total building energy consumption. So that's quite a lot, and it's quite a lot of load to have no sort of precise or effective metering, or let alone any control system. And that's the situation we face today. There is nothing that can do that. Small power is obviously made from the very obvious things like a laptop or a desktop computer, lamps that are becoming more sort of present with lovely kind of offices that are made to look like your home, and lots of lovely coffee machines and hot water taps, vending machines, kitchens, the heaters that people sometimes sneak under their desks to warm themselves up because they find the office too cold, which is unfortunately very common. And then the big kind of printers and copiers and all that kind of thing. So small power, individually, these devices don't really use much power, but when it's scaled across an entire building, it becomes really important and very significant in terms of its energy consumption. So really, small power is definitely not small anymore. It should be really termed large power, right? But these days, it's becoming more and more present, and it's growing all the time with more and more devices. In the UK, we know, or we've calculated, there are roughly about 21 million power sockets in commercial buildings. In the US, there are more. In the EU, there are even more. In China, there are more. In any country with any commercial building, there are power sockets, and they are all unregulated in terms of precise monitoring and in terms of precise control. There is no building management system that can effectively control small power, apart from cutting off entire circuits, which is just not effective. We also know that within that small power load, there is a lot of wasted energy, wasted greenhouse gas emissions, and wasted energy cost. And that can build up and it becomes very significant. We've started a few trials of our platform to prove this point, because it can seem like small power is not really worth looking at, but it really is. And so I've taken just three individual devices from a pilot that we've been running at the moment, and that's a heater, an electric heater that's been hidden under someone's desk, a laptop on a laptop dock where the power management has been turned off, and also a printer and copier that's a specialized version, but left in the corner as the backup copier. Each one of those devices was left on over the weekend because either they forgot to turn it off in the case of the heater, the computer's power management for some reason wasn't working, and we find that a lot with docks and devices plugged in. And the printer and copier actually had a standby power of 127 watts for a backup device. That's an incredibly high power load to just constantly have running. Those three devices, between a period of midnight and 6 a.m, so that's just 6 hours, 1 6-hour period, basically wasted £1.17, roughly 2 kilograms of CO2. Of course, that's very, very small, but when you scale that up to a commercial building size, you can already begin to see that just during that 6-hour period, there was very needless energy waste, but also very needless energy costs and greenhouse gas emissions waste as well. And it can very simply be solved by identifying it and turning it off. So let me introduce you to the ME platform, which is designed very much to solve that problem I just highlighted. It's both a hardware and a software system. On the hardware side, the main and kind of the front end of our system, as anyone would see it, is the ME power socket. And I've explained it's a like-for-like replacement for any standard power socket. It comes in many form factors, from a power strip to a UK version, to single versions, to multiple versions, to EU versions, or US versions. Inside is our technology, and obviously outside is the connection point for a device. On the software side, our main and really the entire brains of our operation is called the ME Hub. And that's where we get the very obvious analytics and data storage elements. But also we have a machine learning feature. And that's really our kind of secret sauce, in that the machine learning is designed to identify and then eliminate that wasted energy. Obviously, the identification is done through our incredibly high quality data that comes from our ME power socket. And the control also is enabled through our ME power socket. So it's a seamless hardware and software system to make an actual impact. On the hardware side, we also have a feature called Tap for Power. And that's quite a simple user registration system that's built into some of our power sockets. It's optional, it's not always on, but it allows one to register with a power socket to supply power for perhaps a given time or a given energy or greenhouse gas limit. Indeed, it can also be used as a potential way to monetize power provision, potentially in a cafe or a shop or something. The other important software I wanted to mention is our ME app and our ME impact indicator. And those two features are really designed specifically for building occupants. We don't want to create a system that basically takes control away from the people that actually plug their devices in. And so we've made a series of both behavioral nudge type softwares and just basic information softwares in the form of an app that really helps people personalize and control their own greenhouse gas emissions and own energy consumption as well, to really try and help get that energy consumption down. So I'd like to take you through a very quick demo of our platform. Now, because of we're doing this on Zoom, I'm just going to show you some screenshots, but it's screenshots of our software that's up and running. But first of all, I wanted to just touch on obviously the hardware side, and you can see perhaps you can see on the video behind me, there's an ME power socket that's plugged into the wall behind me, and that's up and running and powering the lamp you can see behind. And you can see on the screen there that it's a like-for-like replacement. It fits into a standard UK back box. It's not bigger or in any way odd shaped. And you can see a green and a red light on our ME power socket there, and that's our impact indicator system. At the moment, the impact indicator highlights the current carbon grid's emissions intensity of the UK national grid, and it actually focuses on the area that we're based. So green can mean that it's using a lot of renewable energy, for example. It might be a very sunny, windy day in the UK. Red can mean that a lot of fossil fuels are being used, and it perhaps isn't a great time, if you can, not to charge up your laptop or phone. So let me get the screenshots set up for you. So really it starts with the software login, and just to remind you, this is an ME hub, not the ME app, and the ME hub is really designed for facilities management teams to get that in-depth information. So that's why it's kind of a big screen going on. And you can see here we've got a dashboard. It's showing us very roughly how many devices we've got up and running, and giving us some very basic information on the energy consumption of those devices during the past day, and also the power consumption at the moment. So you can see it's roughly using about 500 watts on those 69 devices. We have a way of collating our ME power sockets into groups. And those groups, it's kind of like a tree type view of groups. It starts with all of them, and then it gets split off into logical groupings. So that could be by building, by section, by desk, by person. We can actually group our power sockets by individual power outlets as well. So on a UK socket with 2 outlets, we can even group them by the right-hand side or the left-hand side. And you can see here on the screen that I've shown you, there are 6 outlets listed, which is 3 ME power sockets. And this is the power sockets that control my office that I'm talking to you from today. We can then go into that group and see individual devices. So I mentioned there are 3 devices, and you can see them listed there. We can very roughly see the locations and what kind of devices that are plugged into that device. We can also do filters and basic understanding of the data that's being recorded here. We can then dig right in to seeing the details of that individual device. Obviously, if one wanted to manually control the device, we have the 3 controls here. So we can control the left or the right or both outlets at once. We're also seeing the current carbon intensity, so that's the carbon emissions right now. We can download the data if we wanted to inspect what's really going on. And by the way, we record data at 3 Hertz, so that's 3 times every second we get intense power data coming through. We can see the energy consumption of this individual socket, and we can also see the power consumption of each side of the socket during the past hour and during the past 10 minutes in incredible detail. So if you're an electrical engineer or there was something going on that you didn't understand in your building, our system allows you to really dig into the details and find out what's happening. Finally, I wanted to touch on what we call rule sets. And the very basic way of thinking of a rule set is probably everyone's familiar with a timer, an electrical timer. And that's our very first basic rule, is you can time sockets to come on and off at various times and various days. But we also have what are called limit rules. And those limit rules allow you to say a current power socket can be set up to not use more than, let's say, 4 amps for safety reasons. Or if you didn't want anyone to plug in a certain type of device, you can limit the amount of power that's being used through that power socket. And we use a form of edge computing on our power sockets to immediately kick those rules in. So it's incredibly flexible in how we can use that. So let me return to my slide. So you've seen the features of the ME platform and how it's made up. But really, I wanted to show you how installing the ME platform can make a difference to your building. And forgive the complex looking graph. It's deceptively simple to see once you get into it. So the graph there has two columns, and each column is representing a before and after situation of a 2,000 occupant building. And the left-hand side is the before situation, before the ME platform was installed, and the right-hand side is with the ME platform installed. And you can see the yellow bar right at the top is showing the ME power sockets energy consumption themselves. Of course, they do use power, a very, very tiny amount of power. And you can see relative to other devices, it's incredibly small. And really the point of showing you this is that each color you can see represents a device type. And our system identifies each device and reduces each device type's energy consumption by just a small amount. And it's really at the scale of reducing all of those together that actually a huge impact is made on overall energy consumption. So you can see for this 2,000 occupant office building, we've reduced electricity costs by £26,000 a year. That correlates to a rough reduction of 75 tons of greenhouse gas emissions. And all of that together allows the customer, the owner of the building, to get a payback on our system in just 4 years. That's quite impressive when you think our technology is created to last, the power sockets are created to last for at least 10 years as well. Overall, that's presented a 34% reduction in small power energy consumption. That turns into about a 14% total building energy consumption reduction. So that's quite significant. And digging into how that 34% reduction is completed, we kind of have three main ways of doing that. The first one, which is what I showed you earlier on, which is the very basic, identifying what devices should be turned off when they're turned on. That's one of the big ticket items for us. So that reduces 18%. We then use our machine learning in a really clever way to eliminate off and standby power from devices that are sitting there, not doing anything useful, but obviously still using power. So think of that printer and copier I showed you that was using 127 watts for no reason. And then finally, as I mentioned, we really want to engage building occupants. And so we almost gamify our energy consumption data along with the greenhouse gas emission data. And we set goals for occupants over time. And that enables us to reduce costs and energy consumption by another 7%. We also have a technology called virtual load, and that's our demand side response system. And in a few slides, I'll show you exactly how that can enhance annual savings even more. So kind of refreshing on the advantages and the benefits of the ME platform of what I've just taken you through. Obviously, the very obvious and immediate benefit that you get from using the ME platform is that we can identify and completely eliminate wasted energy emissions, and obviously wasted energy costs. And that's, the kind of all-encompassing benefit. But of course, there are lots of other benefits that come from having a sort of a building-wide real-time network of data that's constantly coming from your power sockets. So first of all, as we've mentioned with the building occupants, we can set building-wide reduction strategies. They can be implemented, they can be monitored, and they can be measured constantly for impact. That's quite unusual for a building management system to be able to do that with both the building infrastructure and the building occupants all at once. There's a very obvious reduction in workload for the teams that operate the power sockets, that operate the power infrastructure of a building, that perhaps have to look at devices and check they're working okay, because it's all automated through our system. As I've mentioned, there isn't any specialized way of installing our power socket. It's a like-for-like replacement. It just requires an electrician, a registered electrician in the UK, to install your power socket and off you go. With a payback of 4 years, it's certainly not bad on hardware that lasts 10. And as I've mentioned, we use a machine learning technique. And actually, we're very confident that as more and more data comes in from not just the building that the power sockets are installed, but from all of our customers at once, we're able to enhance our savings as we go from day 1 to day 20 to day 1000 to day 10,000. Those machine learning algorithms are always hunting and trying to find the wasted energy and emissions. So I mentioned I wanted to quickly talk about our ME virtual load, and I think it's quite an exciting idea. It's something that's perhaps a little far off in terms of how many buildings operate at the moment, but it's certainly completely possible with our system, and we have a few trials of it running. So ME virtual load is very simple. It's a collection of ME power sockets or even certain outlets on certain power sockets. They're designated by a customer or an occupant of a building, and you designate that as usable for demand side response. So that means the grid operator can take control of your power socket and the power load that's in the power socket to do something such as balancing or frequency services. Of course, there are two main ways that demand side response can help with money and emissions. First of all is the very clear and obvious way of saving money, and that's by avoiding peak periods of electricity pricing. So for example, you might know that between 4 and 6 p.m. you're going to be paying a lot more for electricity because everybody else is using it. We can designate certain devices such as a charger of a laptop. We can also tell if the device is being charged up so as not to interrupt that happening. And we can turn that charging period off if it's appropriate to do so, obviously saving money immediately. Also, the National Grid in the UK offers ways to make money from balancing services, and we can offer that through our ME power sockets as well. And we've roughly calculated that if that was enabled and worked as it should, that can offer another 20% reduction on the annual cost of an ME platform subscription. So it's quite a significant technology. So to finish up, I wanted to just introduce you to our team as well. We're not a big team, but we have, I think, made quite a huge impact. And that's really down to the team members that have been involved. So I've introduced myself, and Josh is our co-founder, but also our CTO, and he's been really instrumental in creating all of the technology we use. So he's the man to go to ask questions on technology side. Catherine, who's been with us from the start, is our marketing officer, and she's helped us really uncover the values and ways to talk about that value. Jacob is our research and design specialist, helping us make sure that our platform can talk to devices correctly. And Carlo is our head of branding, making sure everything looks great, including the ME power socket as well. So finally, as I mentioned at the beginning, I'd love you guys to get involved with what we're doing. And there are 3 main ways you can do that at the moment. We're a startup, as I mentioned, and right now we've got our first kind of round of funding completed, and we're running a pilot study in many different buildings in the UK. We've got 250 ME power sockets up and running. You can see one behind me. We've got them in our own offices, and we've got them at various offices around the country. And what we're looking for now is the first stage of investment scale up. So we're looking for innovation investors who want to join us, potentially to perform larger scale trials and pilots, or indeed invest in the company long term. Second way is through partnership opportunities. One of the aspects of our technology that we're really trying to push is that we're not a closed technology. We also don't want to take over an entire building management system. And we are very aware from history of working in this realm that there are so many technologies out there that we want to be as interoperable as possible. And so the only way to do that is to get involved and to integrate with those technologies. So we're looking for help with that. Also, as I mentioned, we're based in the UK. We've got UK technology pilots up and running, but we definitely want to expand to the EU and US as well. Catherine's actually based in the US and will be leading measurable energy pilots from there. And of course, even though we're potentially not as close as we used to be, we're very much open to working in the EU and setting up pilots there. Finally, we're looking forward to our launch period, and that will be in late 2021 in the UK, sometime in 2022 in the EU and US. So if you want to save 20% of your energy bill on your commercial buildings and become basically a leader in sustainability, it's such an obvious thing to do. Please get in touch and we'd love to see how we can work with you. If you'd like to receive a copy of the slides and keep in touch with us, there's a link you can see in the red box at the top there. So please follow the link, and it just asks a few basic details from you. There's also our contact details you can see down at the bottom of the screen. And we're also going to be hosting a live Q&A session for the next sort of half an hour. That's on a Microsoft Teams meeting as soon as this meeting ends. But thanks for listening. I've enjoyed telling you all about us and hope you've enjoyed listening to it.
Perfect. Thank you so much, Dan, for the presentation. And for the attendees here, just to reiterate, Dan will be hosting a live Q&A from around 12:30 to 1 o'clock. The link is right there on your screen. So please join him for continued discussion. I did have one question before we close out here for you, Dan. And looking at seeing you are starting off in the UK, you're looking to expand internationally, especially into the mainland Europe. Do you anticipate seeing an uptick, especially from the nearly zero energy buildings regulations that's going to really hit the commercial market next year in 2021 in Europe?
Absolutely. I think being able to identify new sources of wasted energy within a building that probably have already been tackled traditionally, such as lighting and heating and systems, being able to identify small power as a new source of completely easy ways to reduce energy is almost a no-brainer to get to a net zero position.